Hello, algebra students, and welcome back to another video lesson today as we continue to work with our quadratic equations. Today, we're going to look at taking that standard form and converting it backwards to vertex form. How do we go from standard to vertex? And, one of the things that we really need to be able to understand is, if we have vertex form, what information are we able to get out? And if we have standard form, what information do we get from standard form? And so we want to make sure that we understand why we need both of these forms and what they're used for. So vertex form is obviously for the vertex. It tells us where that middle ground, if you will, that middle point of the parabola is. If I know that's the vertex, I also know then where the axis of symmetry is, because it has to go through that vertex at the x-coordinate. So we know the axis of symmetry. We also know whether or not this is a maximum or a minimum point, right? We can tell if the vertex is maximum or minimum, which means then we also know the range. So a lot of different things coming from vertex. Standard form, though, is really used to help us find that y-intercept. Right, we need that c value after we have it in standard form. And then we can also find the x-intercepts from standard form as well, using quadratic formula. And so we need to know the difference between why we have to convert back and forth. Now, this is a tough chapter, so I hope you're taking notes. A lot of this is new material, new content. And are you trying those practice problems? Because we're going to be having a test, and as those tests and things like that come up, all of these practice problems are really preparing you. For example, you should be able to convert this vertex form, y equals 6 times x minus 3 squared plus 7, into standard form. Why don't you pause the video and try to do that now? All right, remember, when we see parentheses squared, we probably should think about writing it out twice so that we remember we have 4 multiplications. X times x is that x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. Come on, negative 3x. And then negative 3 times negative 3 is positive 9. If we simplify the like terms, we get x squared minus 6x plus 9. Now that's just for the x minus 3 squared part. That was just this. We still have a 6 out front and a plus 7 on the end that we have to use. So we're going to distribute, getting 6x squared minus 36x plus 54. All right, that's called distributing that 6 to all 3 of those terms. And then we have that plus 7 on the end, which means y equals 6x squared minus 36x plus 7. So you should be able to convert vertex to standard form. Again, standard form gives me that the y-intercept is now at 7, or the 0.07. And if I wanted to, I could use this information. If A is 6 and B is negative 36 and C is 7, I could use that quadratic formula to find my solutions. But you need to know how to convert into standard. Today, we're going to look at going backwards the other way, a process called completing the square. Can we go from that end, that standard form, and go back into vertex? And we're going to teach you the beginning of this today and finish more of it up in another video tomorrow. And in order to help us with this, we're going to go back to a process, or we're going to use algebra tiles, back to something you've used. But this process is called completing the square, right? How do I convert y equals x squared plus 4x plus 5 into something that looks like y equals x minus some value squared plus some other value? how do I figure out what all of those values are and what does that mean, right? And so there's a process involved. And in order to be better understanding of it, we're going to go back to our algebra tiles, things that you've used in the past. So how might we model x squared plus 6x using algebra tiles? Well, we start by utilizing, and I'm going to utilize the actual drawing tool here. So we start by utilizing a square, maybe like that, to represent x squared. And then, let's use a different color. We would draw 6 of these to represent the 6 x's. 4, 5, and 6. So there's my algebra tiles that help to represent. We've probably got to make this just a little bit bigger, but we'll figure it out. All right. And so as we see that, what we want to try and do is arrange these, and we'll move some of them over here, in such a way that we can see what they look like as a square. All right, this is the second part. I want to arrange them as a square. So I've got, whoa, I don't want to move that whole thing. Sorry about that. So far we've got the x squared and I've got 3 x's. And now I want to try and arrange it into a square. So I'm going to put these ones going this way. All right, and it's not making a perfect square for me on the computer screen, and that's okay. That happens occasionally. But there you go. Okay. Now we have what's called this hole, right? We have this hole over here that doesn't complete the square. And maybe if I draw that as an outline in black, you'll see that we would need some information over here, what we call some constants, to help us fill in. So how many 1 tiles would we need to fill this in? Well, I would have to figure out the cross section of these 2 areas. And if I draw these accurately, or pretty close to accurately, I mean, how many 1 by 1 tiles? We would need 9. So we would need 9 1 tiles. Now here's the nice part about this, though. We can use this, right? This is an x by x. And these were all 1 by 1 by x, and a 1 and a 1 and a 1 to get my 1. So this side over here, right, this gives me some other information as well. What is the area of our entire square? Well, we've got 1x squared, so that's an x squared, plus I've got 6 x's, those are the yellow tiles, plus I've got 9, so plus 9 of the 1 by 1 tiles. Okay, so there's my x squared. The yellow represent the 6 x's, and these white squares represent 9 of the 1 by 1 tiles. Well, how might we find the length and width of that square? Well, if we look, this is an x plus, what's my numerical value? 1, 2, 3. So that side is an x plus 3. We'll call that our length. So x by plus 3. And then we also have an x and a 1, 2, 3 up here on top. So x plus 3 for the width, we'll call it. So length by width is x plus 3, which means these 2 pieces right here, x plus 3 times x plus 3 and x squared plus 6x plus 9 are equal. They're the same. If I were to multiply all of these out and simplify, I'm going to get that, which shows the area. So they're the same. Now here's my question, and this is maybe the challenging part. Is there a different way to write x plus 3 times x plus 3? Well, I wouldn't ask the question if there wasn't. So this goes back to remembering that x plus 3 times x plus 3 is really x plus 3 quantity squared. Remember, we broke this down when we were trying to get to standard form into this. So this one is also the same as those other two. And what we've done here is a process called completing the square that we'll talk more about tomorrow. We've got to know how to make this information, though, based upon what they're giving us. So let's try another one. X squared plus 8. Right? Why don't you pause the video here and see if you can't draw yourself an x squared plus 8 and then turn it into a square to figure out part B. Once you got to part B, that's a good spot to stop. All right, I hope you took some time to draw those out, right? 1x squared. This is x by x, which means these are all dimensions of 1. So we have this square over here, and we would have 16 left to fill in that hole. So that means we have 1x squared plus 8x plus the 16. Okay, if I try and find the length and width, I've got an x and I've got 1, 2, 3, 4. So I've got an x plus 4 for my length. If you do the same process up on top, we've also got x plus 4. And what's the other way to write x plus 4 times x plus 4? Well, we would get x plus 4 squared. Right? And hopefully you see that that's kind of similar to what vertex form looks like. And so that's what I'm going to encourage you to try for right now. Here's another set. There are 3 of them. And you might notice the shortcut happening already, and that's okay if you notice it. Go ahead and use it. But give it a try. What are the number of 1 square tiles, that hole that you need? And then what's another way to write that expression? All right, so let's see. If I've got an x squared plus 4, that leaves me with an x squared. I'd have 2 and 2 going this way. This is not going to work the way Mr. G wants it to. So I'd have 2, and then I'd have another 2, and then I'd have 2 and 2, meaning I would need 1, 2, 3, 4 of them here. I would need 4. So that would give me x squared plus 4x plus 4. And if I look at the length and width, x and 2, meaning x plus 2 quantity squared. If you drew the same thing out with 8 of them, which we just did, right? We just did 8. I'd have 4 of them along the top, 4 of them along the side. So we would have said we needed 16, which then breaks down into x plus 4 quantity squared. Well, what about 2? All right, that's an x. And if I have 2, that means I have 1 this way, and then I have 1 more this way. So we would only need 1 more to complete the whole, or x squared plus 2x plus 1, meaning we could write it as x plus 1 quantity squared, because I've got an x and a 1 on the top and on that side. So maybe you see what's happening here, right? But we're trying to identify, how do we complete the square? How do we complete that whole by adding in these 1 tiles? Now, there is a shortcut here, right? And tomorrow is going to bring more about how do we use this shortcut. But if you look, when we were writing these, there's a relationship between the number in the parenthesis and the B and that C value, okay? So how are 3 and 6 related? Well, hopefully you see that 6 is double that, right? How are 3 and the 9 related? Well, that's 3 squared. And so there is a shortcut here that will allow us to quickly go from x squared plus 6x plus 9 using 6 and 9. We just need to make sure that whatever number, if we cut it in half here, half of 6, that's 3. If I square that, do I get that value? And I certainly do. So please try today's problems. Today's are more so working on some of these completing in that whole of the square. What do you need and how do you rewrite it? And then tomorrow we'll get more into that shortcut. If you have any questions, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.